When we think of stars, we probably imagine tiny shiny objects in the night sky. At least, that's how we see them from down here on Earth. But stars are anything but small. In fact, one of the largest stars, Betelgeuse, happens to be much larger than our Sun. For years, this star has baffled scientists. However, recently, something more unsettling has been happening with Betelgeuse, making scientists and other well-informed folks very concerned. Join us in this video as we explore the terrifying details about Betelgeuse, its destruction as predicted by the James Webb Telescope, and how this new development will affect our galaxy and our lives right here on Earth. As described by physicist Michio Kaku, Betelgeuse is a cosmic wonder, a giant star that has interested cosmologists for so long. A Greek astronomer named Tmy was the first to discover it. This star is so big that it can be seen in the night sky from Earth during winter. If you're into constellations, you've probably seen or heard of the star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient, and to date, it is one of the brightest stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay constant. Instead, it fluctuates. This fluctuation is one of the unique properties of the star, but it isn't the only one. Let's explore some of Betelgeuse's unique properties. Most of the stars you see in the night sky are actually far from Earth. The closest star is 4.2 light-years away from Earth. If you don't understand how the term light-years explains distance, picture it this way. Imagine moving at the speed of light for a whole year. It's been proven that light can cover a distance of 186,000 miles per second. Hence, the distance light can cover in a year is equivalent to 1 light-year. If you do the math, you'll have billions of miles. So, when we say the closest star is 4.2 light-years away, it means it's billions of miles away from Earth. But guess what? Some stars are even farther, and Betelgeuse is one of them. Betelgeuse is located about 600 light-years away from Earth. So, if you were to go to it traveling at the speed of light, it would still take 600 years. We can't move that fast. Not even our fastest spacecraft can. Yet, this star can still shine so bright in our sky. If you're wondering how Betelgeuse can be so bright despite the distance, that's because of its other qualities, like size and brightness. Betelgeuse is about 500 times bigger than our Sun. Its radius is believed to be about 1,000 times that of the Sun. It is so large that it appears as a disk in space when using sophisticated telescopes, whereas other stars appear as little points of light. The disk appearance is suspected to be an effect of the reactions on the outer layers of its atmosphere. In terms of mass, Betelgeuse measures about 12 to 19 solar masses. Solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 times 10 to the power of 30 kilograms. Scientists cannot determine the exact mass of Betelgeuse because there are no other planetary bodies orbiting around it to compare with. And of course, we can't measure directly from here on Earth. But it's confirmed that this star is at least 12 times heavier than our Sun. The brightness of Betelgeuse ranges from magnitude +0 to +1.6. In more familiar terms, Betelgeuse is 16,000 times brighter than our Sun. No wonder it was nicknamed the Red Giant. However, the brightness of Betelgeuse doesn't stay constant. It fluctuates. This fluctuation is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter, but when it contracts, it dims. This process can occur for 10 to 100 days, or even more. One unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these areas is far more potent than on the regular surface. But the downside is that these strong magnetic spots inhibit the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has many of these spots compared to our Sun explains why it's cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but the ones on Betelgeuse are much larger and very numerous compared to the ones on our Sun. To give you an idea, the spots on Betelgeuse can be twice as large as the Earth. Betelgeuse also boasts a magnetic field that is 1,000 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on the surface of Betelgeuse seem to be in loops or arcs. Betelgeuse has a surface temperature of about 3,500 Kelvin. This low temperature contributes to the low energy emitted by this star and its dim red color. Betelgeuse is a red star. However, it wasn't always red. It was yellowish about 2 million years ago, just like our Sun. Over the years, the color started changing to orange, red, and then about 2,000 years ago, it slowly started becoming the red star we know today. This fact has made scientists believe that the star is getting old. Betelgeuse emits as much as 7,500 times more energy than the Sun. It might have been a fair rival to Earth's Sun if it weren't so far away and in its prime. The fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite impressive. Our Sun is only 8.3 light-minutes away from Earth, which is why it is so effective. If Betelgeuse were just slightly closer, we might even be able to see it during the daytime. But if it were to replace the Sun, it would swallow up or displace the Earth and the other 4 planets close to it due to its massive size. Moreover, even if it could fit, it emits more radiation than our Sun. That alone would make it a bad sun for Earth. So maybe it was never designed to be our Earth's Sun, just a distant giant red star that we could admire and study from afar. The red light from Betelgeuse is even more pronounced because of the distance of the star from Earth. One thing about the universe is that it's constantly expanding. This expansion alters the light rays from objects and galaxies so that only longer light wavelengths travel farther. Red light has a longer wavelength than blue light, so at far distances, blue light will not be visible, only red light. But as fascinating as Betelgeuse has been all these years, one thing remains clear. It is an old star, almost nearing the end of its lifespan. You see, stars become red towards the end of their life when the hydrogen in their core transforms into helium via nuclear fusion. At this point, the star slowly transforms into what space experts call a red giant. And from what we know about stars, heavy stars age faster than light stars. Since Betelgeuse is about 12 times heavier than the Sun, it's dying at an accelerated rate. Also, this star's irregular pulsations and brightness are another strong sign that it's dying. Betelgeuse started dimming in 2019, but the lowest brightness ever recorded of Betelgeuse was in February 2021. This was when concerns about the near-death state of this star began to grow in the science community. But wait a minute, how do stars die? Well, they explode, something scientists call a supernova. So what is a supernova? If you've ever seen a nuclear explosion, just know it's nothing compared to a supernova. A supernova is a massive and powerful explosion that occurs when stars reach the end of their lifespan. An enormous amount of energy is usually released into space whenever a supernova occurs, making supernovas some of the universe's brightest and most spectacular events. However, there are 2 types of supernovas, Type 1 and Type 2. A Type 1 supernova occurs when a remnant of a low-mass star collects matter from a companion star until it reaches critical mass, causing a runaway nuclear fusion reaction. This explosion releases an immense amount of energy, outshining an entire galaxy for a brief period. In the case of Betelgeuse, scientists are particularly interested because it is expected to go supernova in the near future. This event has been predicted for centuries, and recent observations suggest that Betelgeuse is showing signs of imminent collapse. When Betelgeuse finally explodes as a supernova, it will be visible from Earth even during the day and will shine brightly in the night sky for weeks or even months. The explosion will release heavy elements into space, enriching the interstellar medium and potentially seeding new star formation. The James Webb Telescope has been closely monitoring Betelgeuse to gather more data about its current state and predict the exact timing of its supernova. This upcoming event has sparked significant interest and concern among astronomers and scientists alike. Understanding the life cycle of stars, like Betelgeuse, provides valuable insights into the evolution of galaxies and the universe as a whole. As we continue to study Betelgeuse and its impending supernova, we gain a deeper understanding of the forces that shape our cosmos. This knowledge not only enriches our scientific understanding but also fuels our curiosity about the vast and mysterious universe in which we live.